Hey guys, welcome to a new episode of the Kubernetes series and the final one until we revisit the Path to DevOps series. Now today we're also revisiting a topic we discussed about in one of the incipient Kubernetes videos, which is how would we deploy an application to Kubernetes. And today we're going a bit more in depth and trying to follow some other best practices that we might want to have implemented in our Kubernetes deployment procedure. So if this sounds fun, let's jump straight into business. Before we begin, I'd like to give a bit of reasoning for today's video topic. Up until this point in the Kubernetes series, which if you haven't seen, just go down into the channel and search for All About Containers playlist. You have everything in there. Enough self-promotion. We've been talking about a lot of Kubernetes objects, which would help you build your Kubernetes ecosystem. And now the question comes, how do you deploy all of these independent YAML objects in a fashion that's easy for you to maintain and it's easy for you to scale on top of? Yeah. So a basic application that you might want to deploy to Kubernetes, which sits inside of a Docker image, would need quite a few Kubernetes objects, and you can see them on the screen. Yeah, starting from the top, we would need an ingress, and then we might need a service, and then we might need a deployment. Then to the left, we could need a Configmap or a secret, and to the right, we even might need a volume. So how would you package all of these different Kubernetes objects, which are basically YAML files, separate YAML files, into one object that you could call a release? And obviously, you need to take into consideration the fact that you might not need the volume for one application in case you have multiple, and you might not need the ingress for another one if you don't want it publicly exposed. So there's a bit of back and forth in terms of the stack of applications that you have and what exact Kubernetes objects each of those applications need. And in order to answer the question that I just asked, the way I am deploying application to Kubernetes, and I'm not trying to say this is the best way to do it or this is like the standard of the industry, is through HELM. Now, before jumping into HELM, I am acutely aware that there are other solutions on the market, and one of the best ones, and I would say competitor to HELM, and I'm making air quotes because I don't really believe they're competitors. I think they can actually work together, but one of the competitors of HELM is actually Kustomize with a K, and I'm fairly certain that some of you people who are watching this video are aware of Kustomize and will say, oh man, HELM templating, this guy doesn't know what he's talking about. Well, maybe I don't. I'm not saying I know everything, but you are on my channel looking at my video, so maybe you want to learn from me. And the reason I use HELM is because I've been in the DevOps space for a few years now, and when I started working with Kubernetes, only HELM was available, so I picked it up as a package manager for Kubernetes. And Kustomize was only available a bit later on and became generally available with Kubernetes on version 1.14. So I was in the space prior to that, and I picked up HELM, and I kind of enjoyed it, even though it has a steep learning curve. And I believe that people tend to break up the DevOps Kubernetes deployment space in two. It's either HELM, it's either Kustomize. I don't really think it should be like that. I think HELM is a bit more complex, and that complexity can be a burden, but it can also be an advantage. But it's also more flexible, and it hides behind its templating language a lot of utility and power that you would be able to use. While Kustomize goes after the KISS principle, which is keep it simple, stupid. It's just basically like a sed for YAML files in Kubernetes, which is obviously very powerful for any changes you might want to make, but it's not as complex and doesn't give as much logic as HELM. Parenthesis ended. I just wanted to make it clear that if you guys want to use Kustomize, it's up to you. Okay, go for it. I will be showing you HELM and trying to teach you and trying to explain why I chose HELM and how it helps me and what advantages I find behind it. Moving on with only HELM just now as our topic of discussion. As the joke on the screen might have tipped you off, Helm is a package manager for Kubernetes, and it's also a templating language. It's basically a two-in-one. Yeah, it behaves sort of like YAML, but for Kubernetes. It allows you to package all those potent YAML files into one big entity, which is called a Helm chart, and you can deploy that to Kubernetes as a release. That's how it's called. It allows easy versioning and sharing of said charts, and it also helps or makes it easy to maintain a history of your releases, and also allows you to roll back to a previous version. While as a templating language, it's extremely powerful because it features advanced logic like loops, like ifs, conditionals, all kinds of file processing that you might need in your YAML templates. And also it centralizes the changes inside of your YAML files with the help of two specific files, values.yaml and helpers.tpl. Nowadays, we find ourselves in the realm of Helm 3.0, which is a blessing because it's client only, so you just need to install it locally as a binary on your operating system, and you have the power of Helm at your fingertips. Before Helm 3.0, we had version 2, which was a disaster security-wise, and it also required you to install something on your Kubernetes cluster as a server, so it was a bit more cumbersome. Now it's simpler. You just download Helm and you use it, and also it relies on your kubeconfig context, so you don't need much. You just need kubectl installed and a kubeconfig existing on your workspace, and that's it. And then you can just harness the Helm client's power to tap into libraries of charts, and it helps track all of your releases in Kubernetes secrets, which are deployed in your cluster in the same namespace where you deploy your release. Up until this point, I've only been talking about Helm characteristics and features, and I might have scared you off a bit with terms like chart and release, but I want to simplify things for you, okay? So a chart boils down to something very simple. It's basically a folder structure, yeah? And on the screen here, you can see a chart example for WordPress. Yeah, so the folder is called WordPress, and that's basically the name of the chart. And inside of that, you have some interesting files that belong to the Helm chart. And the first one, starting from the top, is chart.yaml, which is a YAML file that contains information about the chart, like the name, the version, and a bit of description regarding the chart. Nothing more than that, okay? Then you have an optional plain text file, which is the license, then another optional plain text file, which is the README, that shows you what the chart is supposed to do and how to install it. Then you have values.yaml, which is basically where you would hold all of the configuration that comes into the YAML templates, and I'll talk about those in just a few moments. You have another optional values.schema.json, which contains a JSON schema for your values file in case you want to lock that down. Then you have a charts folder, which is a directory that contains other charts this chart might be depending on. Yeah, it's like sort of folder nesting, parenting and child sort of relationship. Then you have a CRDS folder, which contains CRDSs, which stands for custom resource definitions. In case you need to deploy your own resources in Kubernetes, that's also possible. So in case, let's say, service from Kubernetes isn't enough for you and you want to create your own resource called fidget spinner, yeah, you could totally do that. And it would be a CRD. It would be a custom resource definition. And then you have the templates folder, which contains the YAML manifests of your resources. Yeah, just like I said, deployment.yaml, service.yaml, everything will sit inside of templates folder, and you would be able to use the templating language of Helm to replace values here and there inside of those templates. And I'll show you how in the demo at the end of this video. And then you have also a notes text file, which basically contains some short usage notes, which will be rendered to the terminal when you release a chart. And it basically contains some instructions. Yeah, like you just deployed a WordPress chart. If you want to access the web page, hit this URL, something like that. As I'm fairly certain this was a lot of information to take in, let's jump into action and see how to create a chart on your own, what it contains. We'll go through it and then we'll actually deploy it. I think I'll deploy it locally, so I don't create a Kubernetes cluster because I don't have one on hand right now, but you will achieve the same result. So let's jump into the demo. Okay guys, demo time. And to keep this as simple to follow along for you, I just have an open folder which is empty in Visual Studio Code, and I have HELM installed. So if we do HELM version, we should see that I am on version 3.8.2. Yeah, it's not the latest, but it's quite recent. Okay, so I would like to create my own Helm chart, okay, to show you it's not that spooky. So if I do Helm and that's it, I hit enter, you will see it brings up the Helm help. And if I look at available commands, I can see Helm create. Yeah, so I can create my own chart based on a blueprint that Helm offers. So I will do Helm create my chart. Yeah. And as you can see, it said creating my chart, and now I have a new folder inside of my empty folder, which is called my chart. And if we expand this, we have that folder structure I was talking about earlier. Inside of charts, we have nothing because we have no charts this chart depends on. And honestly, it's optional, so I think you can delete it. Then inside of templates, we have a test folder, which has a test to check if you can connect to your pod. Yeah, it uses a busybox image. So it basically deploys a pod that uses a busybox image and will do a wget on your service, okay, to check if your actual pod from your deployment got deployed, if the service got posted in front of it, serving traffic, and then you actually hit that service, making sure everything is fine. So what you might notice different and might scare you off a bit, even though this is a YAML manifest for Kubernetes, the YAML of a pod, is this kind of curly braces notation, yeah? And this is all part of Helm's templating language. Okay, so basically, instead of hard coding something here, whenever I deploy the chart, I will give it a full name, and that will be treated as a, let's say, variable, which will be replaced here inside of these brackets, yeah, inside of this placeholder. Let's move a bit on. Now we have helpers.tpl file, which is basically a file that uses sort of the same language we've seen before with the curly brackets defining variables and stuff like that. But what you need to understand is the helpers.tpl file is where you declare your extra functions or extra variables which will help you. Yeah, for example, defining my chart.name. Yeah, in here the Helm team defined this, let's say, variable for us. Yeah, so as you can see here, there are more definitions like this, yeah, defining my chart.fullname. And as you can see, and I told you previously, you can use if statements and else statements, yeah. So it's pretty complex in what it can do. As I said, there's a learning curve with it. You might need to read that official Helm documentation, which was posted on a previous site. Yeah, it's helm.sh. Yeah, I define my chart.chart, my chart.labels. So there's a lot of default variables that I'm getting populated here in helpers.tpl, and then I'm going to use these in my actual YAML files. Okay, so speaking of YAML files, let's move to them. If we look at deployment.yaml, you will see this is actually a deployment YAML file, but again, everything is templated out. Okay, and there are two places information can come from. Generally, this one with include, and as you've seen, my chart full name and my chart labels, they come from helpers.tpl, yeah, from this templating file which creates the helping variables. And also you have stuff that comes from values.something. Yeah, so values dot is actually the values YAML file. So these are like automated variables that get created as soon as you deploy your chart, and these are inputs that you give, and all your inputs will be centralized here. Yeah, so the number of replicas of your deployment, you're not going to actually edit your deployment, you are going to edit the replica count property inside the values.yaml file. As you can see, a lot of logic here. We're not going to go through all of it. Don't get scared, it's fairly simple. Okay, HPA, horizontal pod autoscaler. Yeah, again, if this is if values.autoscaling.enabled is true, then this resource will get deployed to ingress. If values.ingress enabled, then this will get deployed to Then notes.txt, as I said, this is something that will get prompted on your terminal when you deploy a release, and you'll see that in just a few moments. Service.yaml is a service, again, with this templated language weaved in. And service account, same thing, yeah, a service account object with templating language weaved in. Moving on, we have the helm ignore file, which, like any other .ignore, like git ignore or docker ignore type of file, has a list of formats or file patterns that the Helm chart should ignore. Then moving on, we have chart.yaml, which, as I said previously, contains information about the chart, yeah, the API version, the name, a description, the type of chart. You have two types of chart, one application, which actually contains and deploys the application, and other, which is basically a library chart, which can be used by other charts as an extension of their functionality. Then you have the version of the chart, and you have the app version, yeah, the version of the application running inside the chart, okay? And last but not least, we have the values.yaml file, which contains all of the configuration of the chart extracted from those templates, and it's just centralized in this one file. Yeah, so if you look at replica count, if you remember, this was in deployment.yaml. But if we look at, for example, service account, this is information from here. Yeah, there you go. So you have values, service account, yeah, values service account annotations. See, so basically you will configure all of your YAML templates using values from values.yaml. And if you want to configure something in your chart, you just need to edit this one YAML file instead of all the other YAML files. Again, this brings a layer of complexity, but I quite enjoy it. Up until now, we've created a Helm chart based on the blueprint that's available in Helm, and that's not extremely difficult. So we haven't actually modified that, and some of you might be scared of the idea of starting to modify a Helm chart, which is why I'm going to show you right now, up until a certain extent, how to add your own template into the templates folder. And let's add a configmap.yaml, for example, because it's pretty simple. And let's also disable some of these existing YAML templates. So I said disable, we're not just going to delete them, because if you look, for example, at the ingress, you will see that it has an if statement. So if values ingress enabled is false, you will not have an ingress object deployed. So this is all set up inside of the values.yaml file. So if we look for ingress enabled false, and now we will not deploy the ingress. And I want to do the same for the service account create false. And I also want to do it for the auto scaling. Yeah. So you can run Helm template in order to see what will be rendered. And in our case, we got a service, a deployment, and pods that come with the deployment. Yeah, so that's basically all we have right now getting deployed with the chart. We're not applying that yet. We want to add one more thing, as I said, and let's add a configmap.yaml. So it's that easy. You just need to add your template in here under templates, and this should do it. I don't know exactly how a config map will look, but here we go. We have config maps on Kubernetes, and this is the official documentation. I'm taking the first config map that I see. I'm just copy pasting the content and I'm putting it here. Okay. So first things first, I want to make this conditional as well. So I'll just copy the if statement from the ingress and I will add it to the config map. And in this case, if values.configmap.enabled, then create the config map for me. I will also need an end statement. So end, something like that. This should do it. Then I don't like the name. I would like the name to respect the convention of any other. So I want the deployment name. Yeah. So include my chart full name. I'll just copy it from the other YAML manifest and I will replace it with this one. Okay. And then I don't like the data. Yeah, I don't want anything to be hard coded inside of my template. Okay, as I said, this is a template. So what I want to do instead is I want to give it input. Okay, so from values.yaml, let me copy this. Let's create the Configmap section inside the values.yaml, and I'll just create it here at the top. Configmap, then enabled. This will be true because I want the Configmap to be created. And also let's say data and put something here. For example, key 1 value 1, key 2 value 2. Yeah, I want this stuff to exist inside of my Configmap under here. Okay, so what I need to do is to make sure I'm doing something with .values.configmap.data. Okay, this was the name of the key which contained the data I want to ingest inside of the configmap. So I don't know how to do this by heart, and because of this we'll go to helm.sh. Yeah, this should be fairly simple. Let's go to documentations, let's go to chart template guide. Okay, and somewhere around here in flow control, okay, there we go, we're looking for range. Yeah, so range is a loop. It's like a for or like a for each or similar mechanism. So basically what we want to say is for every pair, for every key value pair that we have here under data, let's move it here. Okay, and right here it's not using key value pairs, this is just strings, so it's not going to be helping us. Yeah, there you go. Yeah, you're only using the value. I want the key and the value too, so it needs to be a bit more complex than this. We need a separate data type. And there you go. In addition to lists and tuples, range can be used to iterate over collections that have key and value like map or dict. Yeah, map or dictionary. This is what we want. So we're moving on to read about this. And yes, this is the functionality we're looking for. Yeah, so we're ranging through values.pizza toppings. This is the key, this is the value, and then you just spit them out. Okay, so we need to use this character as well. So data pipe and minus, and then let's paste what I've taken, and instead of values.pizza toppings we have values.configmap.data, and in here I'm just gonna say key and value, and I just want the key and the value. Okay, so I think this should do it. Let's template one more time, and if we scroll a bit up we should see a config map. Yeah, there we go. So we have a version 1 config map with the name, release name, my chart, and the data key value. So I don't like the indentation here, it has too many spaces. I think this should be like this. Okay, this is the right indentation. Let's template one more time. This is one of the downsides of templating. You need to make sure your indentation is correct because this is a YAML file. So if you don't respect the indentation, it will fail and Kubernetes will complain. But right now they are aligned. I have 2 spaces here, which is exactly what I want to have. And then key value, this should be good to go. So now I'm satisfied with what I'm seeing, the template rendering for me. So let's just helm ls. Yeah, we have nothing installed at the moment. So I'm going to do a helm install app and just do my chart. And it's validating on configmap.data. Okay, so I think this is not what we want. Let's try again. There we go. Yeah, so this object here, the pipe and the minus, would say this is a multi-line string, and instead of a multi-line string, this is actually a map, so we don't want that. Yeah, and now because we deleted it, everything got deployed successfully. Okay, status deployed, revision 1. So if we do HELM ls, we're able to see it was deployed in the default namespace. The status is deployed. So if we do kubectl get pod, you'll see that pod is running. Yeah. If we look at kubectl get deployment, this is also running. Kubectl get service, also up and running. And kubectl get configmap, there we go. And let's look at the configmap. And as you can see, the data in here is key value pair that we've given it. Okay, and now if I just want to add something more, like dessert banana and soup tomato, let's say, I'm not extremely inventive right now, we can do HELM upgrade, so app. There we go. Now we have the second revision. Okay, so it got updated. And if we do one more thing to note, this text that you see here, this is actually the text being rendered from notes.txt. Yeah, so you can see get the application URL by running these commands. All of this stuff gets rendered into this text right here. Okay, so just a parenthesis for you to understand better, but we were going to look at the Configmap contents. And as you can see now, we also have dessert banana and soup tomato. Okay, so I think this would teach you that modifying a Helm chart is not extremely difficult. I mean, there is a learning curve. There's a lot of functions you need to understand in the Go templating. Yeah, there's a lot of sprig functions. So if you want to take on this endeavor, go ahead and learn about them. But once you understand the functionality and you're able to use and harness the power of those functions, you'll pretty much be able to package together all these YAMLs and deploy them as one release in Kubernetes. This was it for today, guys. I know it was a long video, but I hope it helped you. If you want to learn more about Helm, please drop a comment down below, and why not like and subscribe if you appreciate this type of content and if you think I should be creating more videos like this, yeah, educational. So thank you so much for giving me your time of the day. I'll see you next time. Have a good one. Cheers.